Hello, everybody. Welcome to today's AP Physics tutorial. This is Mr. Adams, and I'm just going to go ahead and talk to you a little about some AP Physics, some centripetal motion. Um,
Psych! It's time to play the game. It's time to play the game! Hey!
AP problems, centripetal motion. It is no joke. We're going to get into it, brother. Starting off. Let's see my volume actually. How we doing? How we doing on volume? Huh? Can you hear me versus? No, you can't. Hello, test. Hello, test. Okay, all right. So, what we're going to be getting into is this problem right here. In centripetal motion, the first type of thing we'll have to do is derive a formula. The second, what we'll have to do is we'll have to do a comparison problem. And then third, we'll have to, of course, use some rules. So for the comparison, or for the derivation of a formula, let's take a look at this one. An object of known mass, you could ignore that, of mass is requiring to go along a circular path in 1 revolution t. That is what you'll see on your homework. I'll tell you right now, for the one you have to have M, you can ignore that. M's not going to make a difference. But this is the example problem that will kind of prepare you for it. An object travels in a horizontal path with radius r at a constant speed. The object takes 1 full revolution. What happens to the centripetal acceleration if you put it only in terms of r and t? Where do I start? I start with my formula. And the reason why I picked this one is because I want centripetal acceleration. So that's the only formula I have that involves that. However, when I put this in, I know what my radius is because that's given to me, but I don't know what the tangential velocity is. However, I know that I have a formula for tangential velocity that is put in terms of t. I have 2 tangential velocity formulas. I have Vt equals 2 pi r over t, and then V equals r omega. I'm not going to use this one, the bottom one, because I don't know what omega is. So I'm not even going to worry about it. I'm just going to go straight to this top one. Now, since I know everything here, I know the radius, and I know the period, I'm going to come back over in here, plug it into my original AC equation, and when I simplify things out, this is what I end up getting. You'll follow a very similar process with the other ones. Second type of problem is a comparison problem. I am going to be comparing the tangential speed in a new orbit that has twice the radius and half the time period. So what I'm going to do is I'm going to start off with, before I even set the comparison up, I want to compare speeds. So I'm going to put Vt is equal to 2 pi r over t, because I know we have something that has to do with the radius and something that has to do with the period. Now that I have the formula, I'm going to compare the two of them with a ratio. It's going to be V2 over V1, and I'm going to take this formula for V2, and for r and t, for the variables I have, I'll put a 2 next to it, and for down here, I'll put r and t, I'll put a 1 next to it for V1. When I am simplifying things out, I want to get to a point where it looks like this, where we have ratios on top of each other, things cancel out, and I put my r's over my r's, or my t's over my t's. Then at that point, I'll substitute in. I'll make 1 r going to be equal to r like they gave me in this problem, right? So beforehand, I put r1, but I'll actually give the variable that they give me in this problem, will actually substitute it in at this point. And t2 is going to be t over 2. So now I'll go ahead and plug these in. 2r over r times t over 2. And if I simplify that, I end up getting that V2 is 4 times V1. Lastly, I'm going to say ChatGPT messed that up. We're going to move on. And in this one, we have some different choices. And in this, we have a car traveling along a frictionless loop. And what happens in the frictionless loop is that they're asking for the car's acceleration. Now, as we know, things can be speeding up with the car. If the tangential velocity is increasing, then that means that there will be a tangential component and a centripetal component, which means the total velocity would look something, or a total acceleration would look something like this. Remember that from the rule maker. However, this is one of those cases where the acceleration is actually going to be something we look at an instant in time because it's always changing. Because the direction's always changing. Now, in this problem, because this is at the top, we know that there is no such thing as sideways gravity. So that means that at the top, there is no tangential acceleration. There is none at the top. Meaning that the only thing that there can be is centripetal acceleration because this car is traveling in a loop. Now, if this car were even slightly over here, that means that there would be slightly a bit of gravity that would be pushing on downward like this. So it would have some centripetal acceleration like that and tangential like that. But because it's at the very top in this problem, it is going to not have any tangential acceleration. If you're confused about that, it's okay. We're going to learn about that more when we get to forces. But when it's at the top and it's moving sideways, you can say that there is no acceleration because its velocity is perpendicular with gravity. Let's go back to this one. I'm curious about. I might have missed this one. I just want to confirm that I did this. They said that the new orbit has half the time period. T1 is equal to T. Did I switch that up? I think I think I did. Let's see. Well, no. Yeah, these aren't right. Yeah, these aren't right because there are no squares in here that I'm dealing with, so the root 2's are out. It's equal to T1 over T2. Yeah, I did the right thing. That's going to be a ChatGPT thing. This is the right process. I wouldn't worry about these answer choices. I generate the example problems from ChatGPT to look like the ones that we have from the actual work, and it seems like they use the same sort of convention of formulas that they use for problem number 4. Again, but you all know that ChatGPT is pretty bad at math. Anyway, gentlemen, that is it. The game has been played. And you all have been prepared for your AP problems homework. I'll see you all on either Tuesday or Wednesday next week.